Okay, so we're recording this now. Let's find amortization number 3 here. And that was Sukhbir that wants that.
Yes, sir.
Sukhbir Kaur. Okay, I'll share my screen here. Now, many of these answers you've got right, so we'll keep the ones that are looking good. So F, you got that right. And you got G right. But for some reason, you didn't like H here. Or I. So let's figure out what we have to do here. Mr. and Mrs. Norton purchased a ski chalet for $35,500. This must have been in the 1930s, yes. They paid $4,150 down and agreed to make equal payments at the end of every 3 months for 15 years. Interest is 6.79% compounded quarterly. And so you plugged all this in, you found out the size of the payment. And then you used P1 and P2. So let's plug all this in to our calculator. I'll go over to the calculator it'll be better if we can see it there. So can you see the calculator?
Yes, sir.
Okay, let's go through how we'd have to do this. We'll clear all that. So we know this is quarterly. They're making payments at the end of every 3 months. So we don't need the BGN because it's at the end. And the interest is compounded quarterly. So the first thing we're going to do is go, well, the first thing we're going to do is set our calculator to 2 decimals. Second, format, 2, enter, and hit clear a couple times. So now we're going to set the compounding and the payments. Second, PY, 4, enter, and hit clear a couple times. And so they're going to make payments for 15 years. So we're going to go 15 times 4 equals 60. So they're going to make 60 payments. So let's put that into N. The interest is 6.79%, 6.79 into interest per year. Now the present value, it costs 3,000 or 35,500, but they made a down payment of 4,150. So minus 4,150. So they must have actually been borrowing 31,350. So put that into present value. And we're looking for the payment, so we can ignore that. And eventually they're going to owe no money. So we got to tell the calculator 0 into future value. And we're going to go compute payment. And we get 83705. There's a negative sign, but it's not a negative amount of money. That's just the cash flow concept saying they have to pay this. And so that's the size of the payment. That was the answer for A. And then we're going to go second amort, and we're looking at the first payment. So P1 equals 1, enter, down. We need P2 to also equal 1 because we want to focus on the first payment, enter, down. And we get a balance of 3104512, which is the answer to part B. We hit the down arrow. We get 30488, which is the answer you had for part C. Hit the down arrow. And so the interest paid in the first payment was 532.17. So that all works. We hit the down arrow again. And now we want to look at just the second payment. So P1 equals 2, enter, down. P2 equals 2, enter, down. And here's the 30735, which you got, down. 31006, which you got, down. And the interest of $526.99, which was good. Now, how much will they have paid in total after the 15 years? So what we're gonna do, we have a couple of ways of looking at this, and they won't necessarily give us exactly the same answer. But if we use the amortization, we can set P1 to be equal to 1. And then we knew there was 60 payments, so P2 equal to 60. And it says they're gonna have a balance of 12 cents. This is going to be like probably an overpayment of 12 cents. But the amount they've paid is,
Excuse me, sir.
yes,
Sir, in my calculator, when I getting the answer for balance, it show minus 4.7 hash 9.
okay. Now, do you have your calculator set to 2 decimals?
Yes, sir.
And you don't have BGN up,
Yes, sir. I don't have BGN up.
okay? And you went from P1 equals 1 to P2 equals 60.
Yes, sir.
And the other questions, parts B, C, D, E, F, and G, those were all correct?
Yes, sir.
That's very weird.
So when I did question number 7 and 8, I faced same problem with balance. Even the first question, I have some decimal changes in my answers. That's why they are wrong.
Okay. I'm not. Yeah. I'm trying to imagine what might be working differently on your calculator than on this one. Huh. Yeah. Because something's obviously not working right there. Yeah, and you tried to send me a video of your calculator. Is
Okay,
that
sir.
you?
Sir, I sent you by mail or right now?
Yeah, for some reason I couldn't access that video. And it's no good us sharing the screen to look at
Yes,
your
sir.
video because you can't do it on the screen like I can with this
Yes, sir.
program.
Yes, sir.
Okay, we'll have to work on that in a little bit. I'll finish this question first.
Okay, sir.
So the total paid here, how much will they have paid in total in 15 years? If we took their payment, if we take the payment of 83705, so let's do that calculation. 83705, no, 0.05. This is their payment, and times 60, because they're making 60 payments. And so this is the answer they're looking for in H here, right? We just took the payment multiplied by the number of payments, And then they want us to add in the down payment. So go plus, what was the down payment? 4150, 4150. So this is the answer they're looking for when they're saying plus the down payment. And how much interest will they pay in total? This is the amount they paid in total, but the amount they borrowed, we didn't write that number down. So let's store this. Let's store this number. Store this in register 7. The amount they borrowed was 35500 minus 4150. So let's store that in register 8. And now we can go recall 7, which is the total amount they paid, minus recall 8, which is the amount they borrowed. And so that is telling us they borrowed or they paid $23,023. Oh, in interest, but we shouldn't have included the we shouldn't have included the down payment here. So let's do this calculation again. The total amount they paid in payments was 12555.75 minus
So
recall
this
8.
is the wrong answer actually. So you put my answer, which is wrong.
Oh, okay. Let's find out. Oh, the total amount of payments was 50233. Thank you. 50223. 50223 minus recall 8. So the total amount of interest they should have ended up paying is this 18873. So does that make sense what they did there in part H and I? To find the
Yes, sir.
total amount they paid, they just multiplied the payment by the number of payments.
Yes, sir.
Okay. Now, so Sukhbir,
Yes, sir.
can we do this calculation again, but you do the same steps on your calculator, and we'll see. You say everything worked fine until we got to the the last
Amount
step,
function.
the amort. Okay, let's clear this. So let's go back to the original question. Oops, where'd my calculator go? So your calculator is now clear. It's on 2 decimals
Yes, sir.
and there's no BGN up, right?
Yes, sir.
And so if you go second, PY, 4, enter, and clear a couple times,
Yes, sir.
okay? And then you're gonna put in 6.79 into IY,
Yes, sir.
okay? And don't hit clear or anything. And then for the present value, go 35500 minus 4150 and you get 31350, right?
Yes, sir.
And we'll put that into present value
Yes, sir.
and then put 0 into future value
Yes, sir.
and then go compute payment.
Yes, sir. I got
Okay,
the same answer.
you got 83705.
Yes, sir.
Okay, now go second amort.
Yes, sir.
Sir, I don't get same answer.
What's that?
I didn't get same answer. Could you repeat the steps?
Okay. So let's start from the beginning again. On your calculator, you've got it set to 2 decimals, right?
Sir, my calculator is not at 2 decimal.
Okay. Go, whenever you're doing amortization, always set your calculator to 2 decimals. So go second, format, 2, enter, and then hit clear a couple times, okay?
Yes.
Okay, now go second, PY, go 4, enter, and then hit clear a couple times. Good?
Yes, sir.
Okay. And then we want the number of periods was 15 times 4 equals, so 60, and go 60 into n. Good?
Yes, sir.
Okay. And then go 6.79 into IY. And you can see my calculator, right?
Yes.
For the present value, it was 35500, but then they had a down payment, so minus 4150. So the actual amount they borrowed is 31,350. Put that into present value. Good.
Yes.
And then we've got to tell the calculator that at the end of the time, they owe no money. So 0 into future value. Good.
Okay, sir.
And then go compute payment.
Yes, sir. I got the answer.
Okay. Now, without doing anything else, go second, and the second function of the present value is amort. And you should be looking at P1 equals 1, correct?
Yes.
And we're only looking at the first period. So we're going to go hit the down arrow because that's already says 1. And for P2, we also want 1. Enter down. And do you get 3104512?
Yes,
Yes.
sir.
Okay. And then we can go down again and we see 30488.
Yes,
Down
sir.
again, 53217.
Yes, sir.
And then we can set it to P just to look at the second period. Go 2, enter down, and 2, enter down. And so now the balance is down to 3073506.
Yes, sir.
And it'll tell us how much we've paid of the principal, 31006,
Yes, sir.
and how much we've paid of the interest, 526.99.
Yes, sir.
So that's all we wanted to do with the calculator. Because for the part H, we had to calculate those just by hand. So is everybody good with question 3 at the moment? And we'll look at the next question we saw in the chat box.
So when you put P1 is equal to 1 and P2 is equal to 60, I
Sure.
face the problem with balance.
Okay, let's see what happened there. If I go down here again, I get P1. So P1 equals 1. Enter down. And now P2, I'm going to make it equal to 60. So we're looking at the entire mortgage amortization schedule. Enter down. And I get 12 cents.
Sir, I got minus 4.7-9.
Minus 4.7-9. And if you go down arrow again, what do you get?
31350.00.
3-1. And you're sure you have your calculator set to 2 decimals?
Yes, sir. Because I got the same answer that we did just now.
Yeah, that's so weird. And if you hit the down arrow again, what do you get?
18873.03.
Weird. Wonder why. Well,
Sir, I face the same problem with question number 1 and 2. When you check from question number 1, there's a little bit difference between the correct answer and my answer.
yeah. I'm trying to think of what other setting could be set differently on your calculator. Do you see the second function of the future value?
Yes,
Says
sir.
CLR TVM.
Yes, sir.
Okay. Go second and hit that CLR TVM.
Sir, I hit it.
Okay. Now go recall N. What do you see?
60.
60. So for some reason that I'm getting the same. For some reason that clear isn't. That's not clearing everything. Wonder why. Let's try second and clear work. And then go recall N. Still 60. Recall IY 6.79. Huh. Yeah, I'm totally stumped here. I don't know what your calculator is not doing. I can't figure out why it's not getting the right answers there. There's
So my
some, there's
first
some,
and second question are wrong because of this.
okay. Let's take a look at the second question. So, you can see my calculator now.
So could you please do question number 1?
Question number 1 first, okay?
Yes, sir.
So you can see my calculator,
Yes, sir.
okay? So it says create an amortization schedule for a loan of $10,893 that is to be repaid in 3 years, 6 payments, made at the end of every 6 months. The interest being charged is 7.97 compounded semi-annually, and they're at the end. So we have no BGN up, and we're looking at semi-annual payments. So I'm going to go second, PY2, enter and clear. It's 3 years times twice a year. So 6 payments. So that's going into N. And the interest is 7.97 into IY. And the amount they've borrowed is 10893 into present value. And again, we have to put 0 into future value. And we're going to compute payment. And we get 207695. And you get that?
Yes. Yes, sir.
Okay. So now we're going to do the amortization schedule. So we're going to go second amort, and we're looking at the first period. So enter down, still the first period, enter down. And I'm getting a balance here of 9250.15. Oh, they wanted us to do payment 0. So that first one is just the regular amount. So that's good. What I've done here is payment number 1. So
Sir, I got 9250.13.
Yes. I'm getting 1.4 for some reason. And the answer they wanted was 1.4. So that's very weird.
I also got 0.13.
0.13. Weird. So, can we try setting your calculator to 9 decimals? Go. Let's try this calculation from the top again. Go second, format 9, enter clear, and try the whole calculation again. Second, PY2, enter clear, and then we need 6 into N, 7.97 into interest per year, 10893 into present value, 0 into future value, and compute payment. And what's the whole number you get here?
The same.
Okay, and now go second, amort, 1 enter down, and 1 enter down. And what do you get here?
Same.
9250.13. 1257.
Okay, so we both get the same answer there.
Yes, sir.
So now set your calculator to 2 decimals. Second, format 2, enter clear, and go compute payment again.
I got the same 2076.95.
Okay, and now go second, amort, 1 enter down, 1 enter down. And what do you get?
9250.13.
0.13. Weird. Well, Moodle usually accepts answers if they're 1 penny off, but on this question, it's not. But I can make sure it does accept them. Let's try the down arrow again. What do you get here?
1642.87.
Okay, and the down arrow?
434.09.
Okay, yeah, those pennies shouldn't make that much difference. So I'll make sure Moodle will accept that answer, especially as that's weird. I don't know why we're not getting the same answers there.
Moodle did not accept the answer, even if there were 0.50 or 0.540.
50.
Moodle sometimes when it wrong.
Well, if Moodle's only 1 penny out, if it's not accepting your answer and it's only a difference of 1 penny, let me know. I can convince Moodle to accept that.
Okay,
Okay,
sir.
sir. Let's go to the second payment here. Where did we go? Although I set P1 to 2, we can also take a slight shortcut. If we hit compute here, it'll automatically flip over to the next period. Compute, and then we can just go down, down, and look at the balance. So you're getting 7.9 here, and I'm getting 8.1, right?
Yes, sir. I got 79.
Okay. Yeah, that's very weird. And here you get 3.4, and I get 3.3.
Yes,
got
sir.
3.4.
Right now.
But you get the amount of interest rate.
Yes, sir.
Okay. And let's, if I want to flip forward, I can go compute again. And it flips it to 3, and then I just go down, down. And here we're 2 cents out, right? And yet you got 41 here for the principal.
Yes,
Yes,
sir.
sir.
And if we go down again, you got 54.
Yes, sir.
So I go compute here and it flips it over, down, down. 3918. And
Yes,
we're
sir.
arguing about 2 pennies here. Down, down was okay. And hit compute. Down, down. And now we're arguing about 3 pennies. How weird. But I'm going to tell Moodle that those are in fact close enough. And down, arguing about 1 penny. And here we're good. And hit compute and down, down. And now your calculator says you have a balance of 0 here, right?
So when I did right now, I got the same problem, balance equal to 3-10.
Sir, I also got same
3
3-1.
3-10. For some reason, your calculator is giving you exponential notation. So I don't know how to tell your calculator that we don't want to see exponential notation. When it
Right.
ends up with a really, really small number, it's flipping it over into exponential notation, but I don't know how to tell it not to do that.
So what is the solution of this in final exam if we face the same problem?
Yeah, we're gonna have to figure out how to tell it not to do that, definitely. I will go into Google and I will find out how to set the calculator so it's not giving you exponential notation.
Okay, sir.
And when you go down, we're arguing about 1 penny here, and down, and we're arguing about 1 penny here. So the final part here, again, we're only arguing about 1 penny. So I can tell Moodle not to worry about those few pennies that were out here.
Sir, how to calculate the last part?
We should be able to do this just by figuring out the total amount they paid. Clear this. Their payments, see the payment was 2076.95, right? That was their payment, but they made 6 payments. So times 6 equals. So the total amount they paid was 12,461. And the total amount they borrowed was 10,000. So minus 10,893. So
Yes.
by that calculation, they should have paid 1,568.70 in interest. But what they've obviously wanted us to do, because they ended up with this 74 cents. So they wanted us to look at the total interest in the calculator. But this answer here should be acceptable. So I'll make sure Moodle accepts it, but I'll show you what I think they must have done. Go second amort, P1 equals 1, enter down, and P2 equals 6. So we're looking at the whole amortization schedule. So enter down the principal, and here's the interest they got. The total interest when you looked at the total schedule. But that's annoying because they didn't do it that way, I don't think, in question number 3. But according to our schedule, that number is the amount of interest. So when you do that, what do you see on your calculator? The 7.3?
Yes, sir.
Okay. Yeah, I'll convince Moodle that it's going to ignore that penny. So let's look at, you asked about question number 7. Let's take a look at question number 7. So the question number 7 says a $50,200 mortgage is to be repaid over a 10-year period at the end of every month. So no BGN, rounded up to the next higher $50. Interest is 7.29% compounded semi-annually. So this is a a general annuity. So let's figure out the payment and then we'll round it up to the next higher $50. So we'll clear everything. And we don't need BGN, but we're going second PY. The payments are monthly. So 12, enter, and we need to set the compounding separately because it's semi-annual. So 2, enter, and then I'll hit clear. So it's 10 years and there's payments every month. So times 12. So they're going to make 120 payments in total. So we'll put that into N. The interest was 7.29 into interest per year. There's no down payment. So the amount they borrowed is 50200 into present value. It's going to be 0 when they paid it off. And so the payment will go second payment. Oh, I shouldn't have gone second payment. I got to go compute payment. And it's 587.58, right? But it's going, they're making payments to the next higher $50. So the payment is going to be 600. So although we can see 587.58, because they're making the payments rounded up to the next higher $50, we're going to put 600 into payment. Does that make sense?
Yes, sir.
Okay. So we had to find the payment and then we put 600 into payment. So it says enter the number of rounded payments required to pay off the mortgage. Now that they're paying this higher payment, although we knew they were making 120 payments, now that they're paying it slightly faster, we're going to recalculate N. So we've got all of our information in here. We're going to go compute N. And it's 116.41, but that's going to round up to be 117 payments. Okay.
Sir, I didn't get it.
What did you get for N?
Sir, I got a PMT 587.58.
Yes, that's correct. But because we're rounding it up to 600, let's go back to there again. You're going to be looking at payment, right?
Yes, sir.
Compute payment. And you're looking at 587 something.
Yes, sir.
You're just going to type in 600 negative and put that into payment.
Yes, sir.
Because they've told us in the question, they're rounding it up to the next higher $50. So we just have to look at 587 and know that the next higher $50 is going to be 600.
Okay, sir.
Sometimes they do the next higher 10, sometimes they do 50, sometimes they do 100. So these payments are 600, and then we can go compute N. And now you should be looking at 116.41.
Yes, sir. I got it.
Okay,
Sir, I have a question.
yes.
If we got a PMT 587.58 and they told to round off next 10, then what is the answer?
If it was 587, it would be
0.5.
590.
Okay, sir.
So what is the logic behind this 50 or 10 or 20?
Well, sometimes when people are making their mortgage payments, they don't want them to be some funny number with pennies. So they round it up, which means they'll pay their mortgage off slightly faster. And it's easier for them to consider that nice round number in their head. So instead of thinking they're making mortgage payments of 587, however many pennies, they know they're making mortgage payments of $600. It's just easier to think about. And it helps them pay their mortgage off slightly faster.
Okay, sir.
Does that make any sense?
Yes, sir.
Yeah, as far as I know, that's the only reason. It's just easier to think about and helps you pay it off faster. And we can see instead of making 120 payments, now they're going to make 117. So they'll be free of their mortgage 3 months earlier than they would have been. So now we can go second amort. And for part C, we're looking at P1 equals 1. Oh, determine the size of the last payment. So P1 equals 1. But we have to now do P2 equals 117. So enter down, and now 117, enter down. And So they'll end up with a balance of this. Because it wasn't exactly 117 payments, they've got a $354 overpayment here.
So in my calculator, I show the balance 354.82.
I also got the same balance.
352.
354.82.
Oh, okay. Yeah. Um, don't worry about the 1 penny. We'll make Moodle accept the 1 penny. But we're looking, write that number down. I'll write down 354.83. And now we want to look at the principal. Notice what the principal tells us. The principal says they've paid off 50,500 and 54.83. But yours must say 82, right?
Yes, sir.
Yes, sir.
Okay. And then go down to the amount of interest, and I'm looking at 19645.17.
Sir, I got 1.8 in the end.
Okay, so we'll ignore the 1 penny for a moment. What we're trying to figure out here is that we can see that they paid $354.83 or 82 cents too much in the last payment. So what we're going to do is we want to take the last payment, which is $600, and they won't have to pay this overpayment. So take away 354.83, and we'll calculate what that would be. 600 minus 354.83. No, 600 minus, well, I should do it on the calculator so you can see it. 600, which we know is their payment, minus 354.83. And I'm getting 245.17, although Moodle wanted 245.16. But I'm going to tell Moodle we're not worried about those few pennies. But did you understand what happened there?
Yes, sir.
What we knew is the payment is $600, but because they overpaid on that last payment by $354.83, that last payment would only be $245.17. So the next question they want us to do is calculate the amount of interest saved by rounding the payments up to the next 50. So it says use the BH2 plus to find the unrounded payment again. So let's take a look. Clear everything, and let's go back to finding that unrounded payment. Second, PY 12, enter, down, 2, enter, and clear. And we knew they were making 120 payments. And we know the interest rate is 7.29. And the present value is 50200. The future value is 0. Compute payment. So this is the actual payment. And what they want us to do is go second amort and look at the whole picture. 1 enter down, 120 enter down. And when you do that, what do you
So
see for balance?
117. Sir, n is equal to 117. You take the wrong one.
Oh, no, for this part D, they want us to do P2 equals 120.
Okay,
Or-
sir.
Is that what you were talking about?
Yes, sir.
Yeah, they want us to look at how much interest they would have paid if they didn't round off the payments. So if you do the 120 and then you do P1 equals 1 and P2 equals 120, what do you get for balance?
Minus 2.7 hash 9.
Minus 2.7.
So I got the
Dash.
same.
That is incredibly strange. Hit down arrow, what do you get?
50200.00.
0.00. That's so weird. And hit the down arrow again.
20309.13.
Oh, wow. I'm totally stumped here. I don't know why we're not getting the same answers. Jesus, Jesus, Jesus. Oh, I wish we were in a classroom and I could see your calculator. I don't know what to do now.
So actually we use the app calculator. We do not have this calculator.
Oh, you don't actually have the calculator.
Yes, sir. So we use application on mobile.
Oh, I see. Well, something's not working right. Are you able to get the actual calculator?
Sir, I will buy in 2 and 3 days.
Yeah, find the actual calculator and try these calculations again. I've never used the app. I don't know what it's doing.
Okay, sir.
Which you are showing us on the screen, which is this calculator.
I purchased, or I didn't purchase it. I asked the Texas Instruments company to send me this application. But it works the same as my calculator. I don't think it's the same as the app that you're using on your phone. If you contact the Texas Instruments company, you might be able to download this file that I have. But I tried sending it to a student before, and I can't send it. It doesn't work. You'd have to get it from the Texas Instruments company.
By sending them email.
So if we can't use the computer or the calculator, let me show you how to do this on Excel. Okay, so we'll do this question, but we'll do it on Excel. I'll stop sharing the calculator and I'll go over to, first off, I'll have to find Excel here. No. Oh, something went wrong. So can you see my Excel screen now?
Yes, sir.
Okay. Oops. So now we're looking at Excel. Let's go over and do the same question in Excel. The mortgage was 50200. We'll keep track of that. 7.29% interest.
Excuse me, sir. Sir, please zoom your screen.
Oh, yeah,
It's
that's a good idea. Okay, so when we set up an amortization schedule, what we've got to do is we've got to put the number of the payment number in this first column, and it'll start with 0, 1, and it'll go all the way down to, in this case, 120. So we can just copy it down. Excel does a lot of work for us. There we are to 120. And the next column has to be the payment. And so we'll have to figure out the payment to go in here. And the next column will be the interest. And the next column is the amount paid. And the next column is the balance. And the next column I put in here is the rate. And with our rate, we had 7.29, but it was semi-annually, so 2. So the actual rate is this percent divided by 2. So that's our actual rate that we're dealing with. Oh, no, because this is going to be a general annuity. So we're actually going to have to figure out for the rate the value of P. So this is I. Move those over a bit. This was I equals, and now C equals, and the compounding is 2, and the payments were annual or monthly. So the value of C is going to be 2 divided by 12. And then we can figure out, oops, P, which is 1 plus I to the power of C minus 1. That's what we're going to have to figure out here. So equals 1 plus I to the power of C and all of that minus 1. So this is the actual periodic rate we're dealing with because it's a general annuity. So that's what we're going to put into our rate. And we can copy that down because that stays the same for the whole mortgage. So the payment, we worked out the payment, the original payment to be, I can't actually remember what it was before we rounded it. What was it? PY is 120. PY is 12, enter down, 2, enter clear. N was 120. IY was 7.29. Present value was 50200. 0 into future value, compute payment. So the original payment that they came up with was 587.58, right? And we can copy that down because that's going to stay the same for all of these payments. So now the interest, oh, it's not, it doesn't stay the same for the first payment, 587.58. For zero here, there's no payment for the first time period. So that's got to be a 0. And the balance started out at 50200. And so now we have to do the actual calculation because the interest they're going to pay in the first time period here is going to be equal to the payment times the rate. So there's the number we got, or we would have got if we looked at the interest for the first time period, but we can't pay part of a penny, so we have to round this to 2 decimals. So that's how much interest they would have paid. And so the amount for this paid column, this is what's actually coming off their mortgage. We've got to make it equal to the payment, but minus the amount of interest. So this is the amount for the first payment that would come off the mortgage. And then the balance would be equal to this minus this. And once we've done this first period, we should just be able to copy this down for the entire mortgage. So just grab them all grab this little handle on the box and run it down. And notice for the second time period, it's taking the outstanding balance times the rate and giving us the fact that the interest, and notice the interest goes down every time because the amount of mortgage they owe goes down. And that means the amount they're paying goes up every time. And luckily, we don't have to do this. We can just drag it all down to the 120. And what we see at the bottom here is we can see what happened at the very last payment. They would have ended up overpaying by 7 cents. And so we can adjust this final payment by, it should just be equal to this plus the interest. And so we've adjusted this final payment, and now they end up owing 0. So now that we've created this whole schedule, let's go back to the question for a minute and see.
Could you do the payment first again?
The payment question again. Which on
So
the
for
schedule?
payment 1. Yes, sir, on schedule.
Oh, to figure out how we got this 587.58.
So the first row for payment 1, 587.58, 300.43, 287.15. The
Okay.
whole row.
This 587, I figured that out on the calculator, right?
Okay, sir.
And did you get the same answer when you did it
Yes.
on the calculator? Did you get
Yes, I got-
587.58?
Yes, sir.
Okay, we could have done it in Excel, but it was easier to do on the calculator.
Okay, sir.
Then we know the balance was 50,200. And for the this first row here, when we're figuring out the interest, what we're doing is we're taking the balance times the rate. And the rate, of course, because this was a general annuity, the rate was a nuisance to calculate because we had to calculate P. But once we know that, we can just put it in here. So in order to get the amount, this column here is the amount of interest they're paying every payment. And that amount of interest is the balance, the previous balance, times the rate. Does that make sense?
Yes, sir.
So we put that here, and because we can't pay less than a penny, these have to be rounded. So although you can't, it's probably too small to see. This says equal round. Let's on Excel, do you know how to set the rounding to 2?
No, sir.
Okay.
I don't know.
I'll type it in here. Equals ROUND bracket. And then we put balance. Oh. Okay. First off, I got to, maybe I don't need to put it here. Maybe I can do it here. Just put a space here. now you can see what's actually in the cell, right? It says
Yes, sir.
equals, round, bracket, and then this is where I multiplied the balance and the rate. And then comma 2. This sets it to 2 decimals.
Okay, sir.
Okay. And the reason we need to set it to 2 decimals is we can't pay any less than that.
Sir, in balance column, there are some values with only 1 decimal in the end.
Yes, these are all set. They'll all be 2 decimals, but if we viewed them as money, let's view them as money, then it would give us 2 decimals. I can tell Excel to view this as money. See up here, there's a little dollar sign. Says account number format. Can you see that?
Yes, sir.
If I click that, suddenly these are all money. So it was, I think it wasn't giving us the decimals because I had the column set too narrow. Right? The width of the column was too narrow. So it was not showing us the decimals. But now that I've set it to money, we can see all those decimals. Does that help?
Yes, sir.
Okay. So when we look at the question, we could change the payment now. Instead of the 587.58, I could set the payment to the 600 because we've rounded it, right? So if we set the payment to 600, it's doing all these calculations again. But when we go all the way down to the bottom, notice what happened. The 116th payment was positive, and then here's this 354.83 that we saw in our calculator. And so in order to, this would tell us that they're making 116 whole payments, but this last payment is a partial payment. But we could do the same adjustment. We could set to this being equal to the balance plus the interest. And then this comes down to be 0. And so we can see there the last payment was 245.17. Even though Moodle wanted 245.16, this 17 is the correct answer. And then we can ignore payments 118, 119, and 120 because with the $600 payment, they're paying it off in 117 payments. So this is question number 7. Rename Q7. So instead of doing it on your calculator, you could do this in Excel. Part C says determine the size of the last payment. And that's what we've done here, right? And the way we did the last payment was take the previous balance plus the new interest and make that equal to the payment. And then you'll notice the new balance becomes 0, which is exactly what you want it to be. Does that make sense? Can you do that on Excel? If you try on Excel, can you create what I've done here?
It looked difficult, but I will try.
Yeah.
You can try
Um,
on the
the nice thing about having it in Excel is you get to see the whole picture. When you're doing it on the calculator, you don't see the whole picture, but on Excel, you can see the whole thing. That was part C. We got the right answer for part C. Part D says, calculate the amount of interest saved by rounding the payments up to the next higher 50. So they said, go back to 120. So I stupidly deleted my payment, but let's do it here. Let's calculate payment. When we calculate the payment, what do we need? Rate, number of periods, present value, future value, and type. And we know the rate because we just calculated it. The number of payments we know is 120. The present value is the 50200. The future value has to be 0, and it's an ordinary annuity. Oh no, it's not an annuity due. So put 0 here, and I can do equals payment, comma, and so there's our 587.58 again. Let's put that back in here. And I don't want it to be negative. And let's go down to the bottom here. And we'll have to change this because we adjusted it. And so if we want to know the total amount of the interest, we're going to find the total of this column equals sum, and I'll highlight this entire column. And so it's telling us the total amount of interest we paid was 20309.15. And Moodle wanted 20308.9 for some weird reason. Wonder why. Very mysterious. Oh, interest at 120. And so for some reason, if we did that on the calculator, so anyway, we'll go with this answer for the moment. And then if we did this with the rounded payments, so let's keep this one, copy. So we'll keep that number. And let's change our payment now to the 600 and see what we get. And we don't want these last few because they don't count anymore. Let's adjust this to this plus this. And so our balance is now 0. And so we are going to get rid of those last 3 payments. And we're getting 19645.17. And Moodle wanted 19645.16, but we're not worried about that penny. And so if we went equals this minus this, on this schedule, it says we're saving $663.98. And I'll have to figure out what Moodle did, because Moodle thinks we wanted $663.74. So I'm not sure why we're not getting the same answer there. Kind of annoying. I'll have to figure out why there's a difference. But that's what you would do if you're not using the BA2 Plus. You can create the whole schedule and generate the numbers that should be the same as on Moodle. And I'll have to figure out why they're not exactly the same. This number here, the non-rounded, I think the difference might be this number here. I think I forgot to round it. If I look at this number, the whole number, it's giving me all sorts of other decimals. But I don't want all those other decimals. So I've got to go, let's try this again with equals round this number and make it 2. And now let's see what we would get with the rounded number. I think that's why this number here wasn't agreeing with Moodle. So yeah, that was the problem. Now we're agreeing with Moodle. And we can save this number. Equals this. And I'll copy and paste just the value. And now let's change it over to 600 again. And now we can ignore the last 3 payments. And so now we go this minus this. And now we get the answer that Moodle wants, except we're arguing over 1 penny. So Did that make sense? The first time I did this calculation using this answer here, I forgot to round it. So we could generate the same numbers, except for one mysterious penny, using the whole schedule. Do you want me to look at some of the other questions here and do them on Excel so you can see the whole schedule? Let's look at the chat box here. So you wanted to look at question 3 and 7, and you also wanted to look at question 8. So let's take a look at question 8, but let's do it on Excel. So dream that you are purchasing your first house in Port Coquitlam and that you have just closed the deal in which you have agreed to pay $711,000. You're going to put 10% down and finance the rest through the Bank of Nova Scotia. You want to pay monthly payments at the end of each month, and the mortgage will be compounded semi-annually. The interest will be 5.05%. Assume you can maintain this interest rate for the full 25 years of the mortgage. So let's take a look at how we would do this on Excel. Now, are you looking at my Excel screen? Are you looking at the Excel screen?
Yes, sir.
Okay, let's enlarge this a bit. And let's go through the process of what we need to know. To start with, we've agreed to pay $711,000, but we're paying 10% down. So equals 10% times 711,000. So that would be our down payment. So the actual amount we're borrowing is this minus this. So that's the amount we're actually borrowing. What else do we know? We're making monthly payments. And the interest is 5.05%. And that's presumably the annual rate. And we would be nice if it specified it was the annual rate, but we're assuming it has to be 5.05. And this is going to have to be, let's move that over. So I equals 5.05. C equals, let's see, the compounding is semi-annual, so 2, but the payments are monthly, 12. So equals that divided by that. And because it's a general annuity, we need to calculate P again. We'll remind ourselves of what that is. 1 plus I to the power of C minus 1. And so 5.05 is the annual rate, but we're compounding it semi-annually. I'm not sure if we're doing the correct calculation here. Let's find out. This is going to be equal to 1 plus oops, we need to do something with this first. Equals this percent equals 1 plus this to the power of this minus 1 should work. So we have a value for P as long as this thing is compounded annually. And then we're going to have to set this whole thing up again. We're going to have to calculate the monthly payment. So again, let's go over and grab this thing. Copy. And the rate we've just calculated. The number of periods, let's calculate that over here. We're doing 25 years. Monthly is going to equal that times that, which is 300. So we want 300 payments. The present value we figured out up here. The future value is going to be 0, type 0. And that's giving us a monthly payment of this. So this interest rate is 5.05%. But for the periodic, we've got to divide this by 12. So equals this divided by 12. And that's still not giving us a good answer over here for some reason. Why not? Find the monthly payment required. So is this actually semi-annual? So this 5.05 has to be divided by 2 to give us the semi-annual interest. And then we get a reasonable answer over here, and we want to round it to 2 decimals because we know we don't want to use the whole thing. And we want to make it not negative. So now we know what our payment would be. And now we have to set up this whole thing again. Let's go over here and grab these first couple rows. and then try to make sense out of them. This is our payment, that works, or our rate. The balance is equal to this. Our payment is equal to this. And these calculations should be good because we're taking the balance times the rate. The amount paid is still that minus that. And then the amount that comes off the mortgage is the previous balance minus the amount paid. And it'll seem like Excel has to do a lot of work here. But we've got to go all the way up to 300 payments. Oops, there we are. 300. And we should just be able to copy all of these down now and hope that works out to be something sensible. And that didn't work out at all because for some reason this didn't work out. So equals this. Okay, got to copy that down. And that worked because we can see that in the very last period, we have an overpayment of $2.93. So we are going to adjust this last payment, make it equal to the previous balance plus the interest. And now our balance is exactly 0, which is what we want. So it says use the amort function to find the amount of interest. But instead of using the amort function, we're going to add up the interest column here, equals sum, and we'll find the top of this column and highlight the whole thing. I think Excel will actually do this easier for us. So the answer we get from Excel, 48,000 or $482,076.07. And that agrees exactly with the answer that Moodle wanted us to find using the calculator. So that would be how you find the amount of interest once you've set the schedule up. Total this whole column. And that gives us exactly the same answer that they wanted in part B. Now they say accelerated biweekly mortgage. So now consider the mortgage above, but this time you're going to pay accelerated biweekly payments. Find the biweekly payments required. Now, all you have to do here is divide this by 2 for a biweekly payment. Let me put this over here. This is the monthly payment. all they do is divide your regular payment by 2. And we're going to round it to 2 decimals. So our bi-weekly payment should be 1869.97. And you've got the correct answer there, except for the 1 penny. And I will be telling Moodle to ignore that 1 penny. So calculate the number of payments, and the payments per year now is 26. So when you come to doing this on Excel, this now looks incredible because 26 payments per year. Let's go 25 times 26. We're now looking at 650 payments. But we'll find that it's not quite 650 because you're paying bi-weekly payments. You're going to pay the mortgage off considerably sooner. But we'll go to 600 to start with and then see what happens. Or 650 to start with. Moodle or Excel will do a lot of work without complaining. So we'll try the 650 first. And we'll copy all this nonsense down. Let's see. And notice that we're into the negatives here for some reason. Why are we doing that? Round, round. Oh, because we haven't changed the payment. We got to change the payment. So equals this payment that we just calculated. And now let's go down and see what's happening down there. So what's happening here? 639, 416. That times that makes sense. Yeah, we're not getting the interest. We're not getting the interest calculation correct. This rate has to change because now instead of there being 12 payments per year, it's still compounding semi-annually. But instead of 12 payments per year, we've got to put in 26 here, which gives us a different calculation for N. But before we do that, we don't want this to change over here. So I'll copy and paste that. So now let's change this to 26. And let's go down to the bottom of this thing and see what we're doing. So according to this schedule, we're paying this off in 558 payments. Let's take a look at what Moodle wanted. That's right, 558 payments. So on the 558th payment, we end up having an overpayment of $228. So then they wanted us to translate this 558 into years, months, and days. So let's do that. 588. And these were bi-weekly. So 26 equals 588 divided by 26. What we end up with here is 22 years. So go minus 22, not equals 22, equals this minus 22. And so now we have part of a year. We can go multiply that by 12 equals this times 12. So here we decided this was 22 years, and now we have 7 months, but let's get rid of the 7. So equals this minus 7. So this is part of a year. And now we want to go, oh no, this is a month divided by 12. So equals this divided by 12. And so then we can take this and go times 365 equals this times 365. And we get 11 something days, but we'll round that to 12 days. And let's see if that's what Moodle wanted. Moodle's saying 21, 5, and 17. Why is that? 550. Oh, notice I wrote 588, but we're really at 558. It helps if you don't transpose the numbers. 558. So this would be 21 minus 21 would give us 5 months minus 5 here. And this would give us 17 days. So this was years. So Moodle wanted 21 years, 5 months, and 17 days. So that would work for those answers. And then they want us to find the amount of interest with this new payment. So we'll go equals sum, oops. And we'll add up the part of the column that we're using now. Down to here. And that's telling us 403,314 and 38 cents. And amazingly enough, that's exactly the answer that Moodle wants. So now they want us to compare the biweekly to the monthly. How much money would you save by choosing the accelerated biweekly payments? So we have this number, and we had the interest up here somewhere to find the amount of interest before of 482,076. 482,076. 0.07. And so we can look at the difference between these two. Equals this minus this. So by choosing the biweekly payments, this is telling us we're saving $78,761.69. And that's exactly the answer Moodle wants, 78,661.69. So so this was the interest paid and this was the interest with monthly payments. And then they said, how much earlier would your mortgage be amortized, paid off if you chose the accelerated biweekly payments? And so what they want us to do is to convert the 25 years into biweekly payments, which is $650, and then subtract the number of biweekly payments from $650. So let's go back up to where we calculated this. Let's go 650 equals 650 minus the 558. So we're actually paying this off in 92 payments sooner. So now we have to do all these calculations again. These are 92 biweeklies. So this would be 26 equals this divided by this. So we can see that we're dealing with 3 years. Go this minus the 3 to get rid of the 3. And so this is part of a year, but we want to turn it into months. So we'll go times 12 equals this times 12. So we can see that we're dealing with 6 months. So get rid of the 6. Goes this minus 6. And so this is a month, but we need to turn it back into a year. So we're going to go this divided by 12. And so we now have part of a year. And we're going to turn it into days. So 365. So equals this times 365 gives us 14 days. But in this case, we want to round it up, or no, down to 14. Because we've already got 17 days here. And if we round this up to 15, the 17 and the 15 will give us our last month having 32 days. So this has to round down to 14, which gives us a month with 31 days. And we can check here, Moodle wanted 3, 6, and 14. So I should put a label or a title on this. This one was converting so I will save these calculations for you. This was question number 8. Let's try that again. And let's go back to the chat box here and see what other things
Excuse me,
people
sir.
wanted to do.
Excuse me, sir.
Yes.
When you calculated for a payment, how do you convert negative number into positive in Excel?
Oh, okay. Here, I'll do it down here. I went equals, and then I just put a negative sign. Does that make sense?
Yes, sir.
I think what they do in the textbook, if they go equals this, and I think they do times -1. I'm not sure why they do it, but I just put a negative sign. But you can do it either way.
Okay, sir.
Any other questions on this before we look at another question?
No, sir.
Okay, so that was 8. Compound interest number 10, amortization. So that's difficult. That you're just saying compound interest 10, amortization. So Gurminder, which questions in particular did you want to look at? I've noticed you've put question 1, 2, 3, 4, 5, 6, 7, 8, and you've asked me to record the class. I have recorded the class, but which question would you like to look at next? I don't think Gurminder is still with us. So that's bad. Sukhdeep, you said I could not solve amortization, but which question would you like to look at? So Sukhdeep, which particular question would you like to look at? Oh, I can see Sukhdeep is still here, but we're not connecting. So how about Avilia? What was your question?
So my question is
Nikki.
first, second in
Oh, Sukhdeep. Which question?
first, second, and eighth.
First, second, and eighth. Okay, now we just looked at question 8 on Excel. Did you want to do it on Excel? Or do you have the calculator? Or you're using an app?
An app.
Okay, so let's do question number 1. Let's go over here and do it on Excel because I don't know why it's not working on the app.
Okay, sir.
So, yeah, that's weird. So let's find your so and question number 1, okay? So Dahi Bak wants you to create an amortization schedule for a loan of 7517 so that she is to repay in 2 years 4 payments made at the end of every 6 months. Interest being charged is 6.67% compounded semi-annually. So first off, let's make this larger. And let's put the information we want here. 7517 is the amount of the loan. It's going to be 2 years, but it's semi-annual. So equals this times this, which is the 4 payments that they told us. The interest is 6.67%, but it's compounded semi-annually. So equals this percent divided by 2. And find the payment required. So let's go over and grab this piece of math. And so the rate we figured out is this. The number of payments we figured out is 4. The present value is the 7517. The future value is 0. The type is at the end, so that's good. So we're getting a monthly payment here of 2038.50. And that's exactly what they want in Moodle. So that's good. Let's find this schedule. Once you have the schedule set up, you can use it over and over again. Makes life easier. The rate we figured out was this. The balance we figured out was this. The payment we figured out is this. And so what do we know here? We're only going for, oops, 4 payments, not 650, which is nice. We're calculating that. Oops, where did that go? And we're getting this. So we should just be able to copy this down. That didn't work for some, oh, that didn't copy. Equals that. And that worked, gives us a 1 penny underpayment at the end of the 4 payments. So now for the first, where it says the payment 0, the outstanding balance is the 7517. The amount of principal repaid is 0, and the amount of interest paid is 0. So that's this. They're looking at this first row. Now we're going to look at this second row. The amount of the outstanding balance is right here. And that's exactly the number they want on Moodle. The amount of interest, the amount of principal repaid is 178,781. We can see that right here. And the amount of interest paid is 250.69. We can see that here. So this is what we get with P1 set to 1 and P2 set to 1. We'd be looking at this row here. Does that make sense? Understanding the relationship between what you get from the calculator and what you can see on Excel.
Yes, sir.
And then for the next row, this is what you'd be getting. You'd be getting balance. Let's put what they are in on the calculator. This is just called BAL. This is called PRN. And this is called INT. Oops. So that's sort of what you would see on the calculator is BAL, PRN, INT. And these are the numbers. So this is where P1 equals 1 and P2, oops. Equals 1. And this would be where we've put P1 equals 2, P2 equals 2, and then 3 and 3, and 4 and 4. And let's see. Yeah, they also get 01, which is an underpayment of 1 penny. For the amount of principal repaid, they get this 1972.71, and the interest 65.79. So you could get all these same numbers off Excel very easily once you figured out how to set up the schedule. Do you think that will help you?
Yes, sir.
Okay, we'll save that. Oh, find the total interest. In this case, we've got to add up the interest column. I always do this the hard way. I do equals SUM, and then I highlight it. And 637.01 is the exact answer they're wanting. Now, I think that Excel tries to make this easier. Notice up here, there's this FX button. And you can find some. And then it'll ask you for the space. I personally don't find that any easier than just typing it in myself, equals sum. But if you're not sure about what the command is or the function, you can go up here, and you can find them. It'll give you a whole bunch of them that you can choose from. So that's what we would do, and I'll save that under, oops, that didn't work. Q1. Let's take a look at question number 2. It says, create an amortization schedule for a loan of 11,286 that is to be repaid in 9 months and made at the end of every month. Interest being charged is 7.87 compounded monthly. So let's do that. This is question 2. So let's enlarge this. And let's make a note of the information we want. 11,268 is the amount of the mortgage. 9 months. They've just told us it's 9 months. So that's just the number of payments. And 7.8 compounded monthly. So 12. So equals 7.8% divided by 12. So this is the periodic interest rate. And that's all we need to know there. To find the payment, let's grab this whole thing again. Copy. Bring it over here. Paste. And the rate was this. The number of payments is 9. The present value is this. And these are still 0 and 0 because they're at the end of the month and it's not annuity due. So we end up with this number up here, but we want to round it to 2 decimals. So I go equals round this, comma 2, and I put a negative sign in front of it. So we're deciding the monthly payment here is 1293.04. And for some reason, Moodle doesn't like that answer. So what did I do wrong? Again, I transposed the numbers. 11,268, it's actually 11,286. Amazing that I can become a math teacher and be dyslexic, but I've struggled with it my entire life. So now that we've fixed that, I got 1295.11, and that's the answer we wanted. So now we want to create the schedule, but we're going to be lazy and we're going to just steal the schedule we have. So now we've stolen the framework. Let's find the bits we need. The balance is this number up here. The rate we've calculated over right here. The payment we've already calculated over here. And everything should be working now. And we're going to go down to 9 payments. Oh, too many. Let's get rid of these 2 rows. So we can see this is working fairly well because the 9th payment, we've got a 4-cent overpayment. But this should be our schedule. So now we can just read these numbers off and see how we're doing. Payment 1006425, yes. 12175, yes. 7336, yes. So that's payment 1. Let's go down and look at payment number 9. There's the 4 cents overpayment. The 75, 1286.75 and 8.36, and find the total interest paid on the loan. Again, let's sum up this column. Equals sum of all of this nonsense. $369.95, $369.95. So if you're not getting anything sensible out of your BA2 plus, it'd be a very good idea to learn how to do this on Excel, because Excel will give you the exactly correct answers. If it doesn't, then we'll find out why Moodle is not happy. So does that make any sense for question number 2?
Yes, sir, I got it.
Which other question would you like to do?
8th,
Okay, with your numbers, let's find them. Okay. Let's go Q8 again. Uh, 8A.
sorry, sir, 3rd,
What's that?
3rd.
You'd like to do question number 3.
Yeah.
Okay, question number 3 then. Let's find it. Mr. and Mrs. Norton purchased a ski chalet for $38,900. They paid $4,000 or $4,270 down and agreed to make equal payments at the end of every 3 months for 15 years. Okay, so let's make a note of what we need. Let's enlarge this again. And they paid 3,800. Let me know if I transpose any numbers. And they've made a down payment of 4,270. So the real amount they borrowed was this minus this. So they're borrowing 34,630. They agreed to make equal payments. So 15 years we're talking about, but they're quarterly. So 4 equals this times this. So 60 payments. Interest is 3.68. quarterly, so 4, so equals 3.68% divided by 4. So that's the actual rate. It's not a general annuity because the payments are quarterly and the compounding is quarterly. But we need to find the payment. So let's grab our payment calculation, copy, bring it back over here and go paste and fill it in. The rate is good. The number of periods is not good. It's got to be 60. The present value is after the down payment. And we want it rounded to 2 decimals and we want it positive. So let's find out if that's what they wanted. 75363. So this answer is as good as it's going to get. So now we need to do the schedule. We'll be lazy and grab it all. Copy. And paste. So now we have to fill in what we need. The balance is going to start with this amount. The rate we figured out is this. And the payment we've figured out is this over here. And we know we're going to 60 payments. So now we make Excel do a lot of work. $60. We should just be able to copy this down. Let's try it. And we can see that it's working because once we get down to the 60th payment, we can see that we are down to, in this case, an underpayment of 3 cents. And we can make a final adjustment for this final payment of equals this plus the interest. And now this comes down to 0. And this final payment shows the extra 3 cents now. So now that we've created the schedule, let's look at what they're asking us. What is the balance after the first payment? And we got 34194.97, and that's exactly what Moodle wanted. And the principal paid off in the first payment 43503, and that's exactly what we've got on the schedule. And how much interest is paid in the first payment? 31860, and that's exactly what we've got here. So we can answer B, C, D, E, F, and G from that. And then how much will they have paid in total after 15 years? Now, we'd be adding up the principal column, but unfortunately, I don't think that's what they did on Moodle. They just multiplied the payment by the number of payments to get how much will they have paid. So if we added up this column, what would we get? Cool. Sum Yeah, because I've adjusted this, we have an extra 3 cents here. So they haven't adjusted this. They've just done it with the 3 cent overpayment not being included in the last payment. And that's exactly the answer they get on Moodle. And then they've added in the down payment. So equals this plus the down payment to see how much they've actually paid in total. So 4,948,780. 4,948,780. So this is the total amount they've paid. So that's the total amount of payments. And this is the total amount paid, including down payment. And then how much interest will they pay in total? Again, we're summing up the interest column, sum of the whole column. Now, when I sum the whole column, what I do is I do shift and the down arrow. And I'm getting 10,587.83. And they're getting 10,587.80. So I have that extra 3 cents in here. And I'll have to. So how did they calculate that? Oh, I see. They did this payment. The original mortgage. Let's put this here. And the original mortgage was this. And so they did equals this, which is the total amount they paid in payments, minus this to get 105,870.80. So that's a bit annoying that the schedule gives us an extra 3 cents, which is this 3 cents overpayment. But they calculated it just by hand, basically. So if you come up with a situation where you're giving me this answer, the answer you get from the schedule, and Moodle is wanting this answer from doing the calculation by hand, send me an email and I will tell Moodle to accept both these answers because they're both reasonable answers. So does that make sense for how to calculate question
Yes,
number
yes.
3?
Yes, sir.
Okay. Which question would you like to look at next?
So chapter 7, please. I put it
Chapter
in the chat.
7. Okay. chapter 7, okay. Let's do that. Let's,
So it's 8th question. If I attempt the same question wrong, then I'll have to attempt it again.
okay,
Can you please?
I will find it and we'll take a look at it. Chapter 7.
So I also have some issues with Moodle in chapter 6b.
Okay, let's do chapter 7 first. And this is Puja, right?
Yes, sir.
Okay. And you want to
Sir,
look at your second attempt?
Yes, sir. It's 8th question.
Okay. Find the equivalent replacement payments. So we won't do this on Excel, although we could do it on Excel. But we'll do it just on a whiteboard. Let me save this. File, save as. Okay. So we'll stop sharing that. Go to the whiteboard. We don't want this. Let's bring this over. Oops, that didn't work. So what do we know here? The original scheduled payments were 596 that were due 6 months ago and 710 that is due in 6 months. And we're going to replace this with one payment because it says replacement in full. And it's going to be today. The focal date is today. So the first thing I'm going to do is draw what I call a timeline. And let's put on here what we know. Here we are at -6 months. And we or someone was supposed to pay $596. Here we are at today. And we also have 6 months in the future. And we were supposed to pay $710. But they've said, make the focal date today. And so what that means is that this number has to move to the focal date. And this number has to move to the focal date. So let's do those calculations. 596. If we're moving forward, it's going to be multiplied. 1 plus, and the interest rate is 5.25%, or no, 5.2%. So 0.052. And it's moving 6/12 of a year. So 6 over 12. So we need to calculate this. So 6 divided by 12 times 5.2% plus 1 times 596. And with our calculator set to 2 decimals, this becomes 611.50. Do you get the same answer there?
Yes, sir.
Okay. Now this amount here is moving backwards. So we're gonna have to divide it. 710 over 1 plus 0.052 times 6/12 of a year. So I'll start at the bottom. 6 divided by 12 times 5.2% plus 1. Then I can hit the 1 over x key, and I can go times 710. And I'm getting 692.01. Does that make sense?
Yes, sir.
And then we're paying one payment, so I've got to add these two together. So 611.5 plus 692.01. I'm getting 1303.51. And I'll be really sad if that's, oh, well, we can't tell if that's what Moodle wants or not, because you haven't done it yet.
So I get confused about regarding the backward and the forward lines.
Well, just keep in mind that if money goes forward, you're always multiplying, right?
Yes, sir.
Let's make a note of that here. Oops, that didn't work very well. And if you're moving money backwards, you're going to divide. Just keep those two concepts in mind. When you're multiplying, the number gains interest. And when you're dividing, it loses interest.
So what about the replacement payment? If some payment are in the replacement payment, what should we do?
Could you say that again? I didn't understand your question.
So when there is any amount given in the replacement payment, then what is the logic behind this to solve this?
When there's any amount,
In the
Um,
replacement payment,
when it says in full,
in this question we have given in full, but
Yes.
in some
in full means we're going to make one payment. The payment we make completely pays off the bill.
okay, sir.
Okay,
Yes.
I can save this. You wanted to look at a question from chapter 6?
So chapter 6, we have some issues with the Moodle. Some mistake like 5.50 like this.
Okay,
Can you
let me find
check?
that.
Yes.
Is it chapter 6, part A or B?
B.
B. And is it question 1, 3, or 10?
So it's 1.
Okay, let's bring that over here.
So I don't want a solution that I have issue in B part that I got correct answer, but in the last digit have problem.
The only one you got wrong was part C. Let's see why. Point 2465 60847. So they want 9. Yeah, they want 9 decimals, and you've given them 1, 2, 3, 4, 5, 6, 7, 8. And you've given them 8 decimals.
So no, it's
On-
9 decimals.
Yours is 9.
Yes, sir.
1, 2, 3, 4. Oh, you've got 4, 6. They wanted 4, 7. I would say that should be close enough, and Moodle shouldn't get stressed there. Let's tell Moodle that answer of yours is close enough. Let me just change that. Okay. Yeah. That's just unfortunate. Moodle is so picky, but a human would have marked that correct. So let's regrade that.
Six, also in third question, I don't understand the last part.
Let's take a look at it. Break even percent of capacity. Moodle wanted 61.39. So you got everything else right. So let's see why. Break even dollars. Let me put this up here. Break even dollars, you've got. Can you see the whiteboard?
Yes, sir.
Okay, so make sure I don't screw up any of these numbers. 50582 5828.83, and they gave us a capacity X equaled 824,000. And so percent of capacity should be equal to 505,828.83 divided by 824,000 times 100. Let's calculate this and see if Moodle is way off base or not. 505,828.83
I got the correct answer.
divided by 824,000 times 100, and I'm getting 61.39.
So actually, it was my mistake. I divided the BE X over the sales. So it was my mistake.
Okay, because yeah, this is the answer that Moodle's looking for.
Yes.
So
sir.
you're not worried about that anymore?
No, sir, I will reattempt the quiz.
Okay. What other question did you want to look at?
Let me check, sir. Wait a second. So it's actually part 6A. I have issue with this.
Chapter 6, Part A.
Yes, sir.
Okay, let's look at that. And it's question number 8.
Yes, sir. Sir, in B part, I got the both answer, but I don't not able to understand that why it is wrong.
Oh, it looks to me like you've done the calculation correctly, but you've just forgot that they're talking about 100 boxes. That's what the hint there says, be aware, you're being asked for the total cost of painting supplies, not the per box cost. So you've calculated 11.01 per box, but you've got to go times 100 and you get $1,101 that they could paint or they could spend on paint and painting supplies.
Yes, sir.
So you're doing the calculation correctly. You're just forgetting the last step.
So could you please fix it, because I have to attempt the again. There are so many assignments other.
No, I can't fix that because Moodle won't accept that answer. Moodle wants you to multiply it by 100. So you're sitting at 9.5, which I would just leave it there. I wouldn't worry about getting 10 out of 10 there. Just stick with the 9.5.
Yes, I will reattempt it. I want to get 100, 10 out of 10.
Okay, it'll be good practice before you do the final to redo
Yes.
it. So, Nikki, you've been very patient. Sukhbir has asked, how can I search today's class on YouTube? I could send you the link.
Okay, sir.
Once I download it. So Nikki,
So
you're,
can you mail it, the link?
can I send it to you?
Yes, sir.
I can't send it yet. What I have to do is once we're finished, I have to download it and it takes a long time. So send me an email reminding me that I will send you the link. Are
Okay,
you
sir.
able to find my YouTube channel at all?
Sir,
Is-
I have only searched for amortization the last week. I find that video only.
You find that one on YouTube?
Yes, sir. But I don't know how to use a caption for today class.
Oh, no. I'm recording it and then I'll send it to you. I'll send you the link once it downloads.
Okay, sir.
Okay.
Thank you, sir.
So Nikki, chapter 13.5. What assignment is that? Oh, perpetuities. Okay. Let's take a look at them. So question 2. Okay. So I'll bring this over and put it on the screen here. So Ellen Dupree wants to set up a scholarship fund for his school. The annual scholarship payment is to be $2,700, with the first such end of period payments due 4 years after his deposit into the fund. If the fund pays 7.36 compounded annually, how much must Alan deposit? And notice the hint I've given here. We should bring that over because we'll want to take a look at it. So the wording here is tricky. The first payment is due 4 years after his deposit, but payments are to be made at the end of the year. Excuse me. So his deposit really only has 3 years to accrue interest before the perpetuity period starts. So when we try to draw a little diagram of this, he's going to deposit a certain amount of money. And this money is going to grow for a certain amount of time. And then it's a perpetuity. So they're just going to make payments supposedly forever. And we know he's depositing 2,700. And we know this time period here looks like 4 years. But the problem is the perpetuity is at the end of the payment period. So this thing really has to start at 3 years in order to make the first payment right here. So his $2,700, oh no, that's the payment. That's not the amount. The first payment of 2,700. Over here, we don't know how much he's depositing. That's what we're being asked to find out. But the first payment is right here. And so we can figure out how much money has to be here by the perpetuity. So the perpetuity payment, the payment is equal to the amount. So the present value times the interest. But we don't know that, of course, so we can't calculate that yet. What we need is the present value equals the payment divided by the interest. So 2,700 divided by 7.36%. 700 divided by 7.36%. So that tells us that they've got to have 3,000 or 36,684 and 78 cents there. And that's right here. So now we have to figure out how much money has to be invested that can accrue interest for 3 years. So again, we're calculating present value equals the future value, 36684.78 divided by 1 plus I to the power of 3, because this is annual. And we know what I is. It's the 7.36%. So let's try that. 7.36% plus 1, y to the x3 equals that. 1 over x times 36684.78. And we're getting, or I'm getting, 29645.47. Moodle wanted 0.48, but would have accepted 47 as a perfectly good answer because it's not worried about that penny. So does that make sense what happened there? The tricky part is right here with the fact that we only have 3 years. Because the annuity period, the payment is at the end of the period. So although the payment is due 4 years after his deposit, the money really only has 3 years to accrue before it gets into the annuity period. Does that make enough sense? So let's clear that. You wanted to look at question 4. Yes. Yeah, most people do. That's very tricky. Understanding. And that's why I tried to put this hint here to let people know that the annuity period is really only 3 years. Let's look at, you asked for question number 4. And that's the same problem. Notice the hint I have here. Consider the hint in question 2. It's the same problem of when does the annuity period actually start? Which is quite annoying, but it's just the way they end up needing to be. So the faculty of Eastern College collected 14,000 for the purpose of setting up a memorial fund from which an annual award is to be made to a qualifying student. The money is invested at 5.91% compounded annually, and the first end of period annual award is to be made 5 years after the money was deposited. But if the payment is going to start in 5 years, the annuity period is really only 4 years. Let's try and draw a picture of that. They put the money in, it earns interest. And then there's going to be payments coming out supposedly forever. And we know this, in this case, they put in 14,000. But if the payment has to be come out in 5 years, if this is 5 years, the annuity period in fact starts right here. Or no, the interest gathering period is only 4 years. And then the annuity period starts. So this 14,000 gathers interest 1 plus I for 4 years before the annuity. So this is the deferral period. And this is the annuity period. So what does I equal here? I equals 5.91% annually. So it's just 0.0591. So this should be 17,614.73. And then we can figure out the annuity. We're looking for the payment equals present value times I. So equals 17,614.73 times I. And I'm getting 1041.03. So the big problem is here. This looks like should be so does that help? Nikki? Yeah, and that's very tricky about that that exponent in those questions because of when if the payment had been at the beginning of the payment period, it might have been different. But with the payment being at the end of the payment period, then we have to back off by one period, or in this case, 1 year, to include that year in the annuity, not in the deferral. I don't really know how to explain that any better, but once you see it, you can see how it works. And that's why I have the hint there to try and steer you in the right direction. Do you have other questions? Questions for assignment 6A? Okay, let's look at them. Question number 2. Okay, so a firm manufactures a product. Let's bring this over here. Now, the only reason you got the first one wrong was the spacing, and the same with the second one. But I can tell Moodle to accept whatever spacing you put, but I have to do it individually. But I'll do that right now, because Moodle was expecting slightly different spacing. But that doesn't mean your answer is wrong. I can't fix the second one because you're telling me fixed costs. Maybe I can fix it anyway. Because you've basically got the right idea there. Just on the final test, make sure you put total cost here, not fixed cost. But for now, it won't matter. And I can't do anything with part G because you've given me 804%. For some reason, you've got the decimal place point in the wrong place. Does that make sense? Let's look on the whiteboard. I'll show you what I mean. You can see the whiteboard. Percent of capacity. You worked out that the break-even point was 185. And they told us the capacity was 230. So 185 divided by 230 times 100 is 80.43. But you've gone, instead of times 100, you've gone times 1,000 and got 804.35. But that won't work. It's got to be times 100. So what other question did you want to look at? Question 8, okay. So weirdly enough, you got this one correct, the bottom one, but not the top one. I wonder why not. Woody Woodworks makes and sells cedar planter boxes, charging $37 per box. So we know S equals 37. He's purchased tools costing $6.95. So fixed costs equals $6.95. Wood and other supplies cost $9 per box. So variable cost equals 9. And we're looking at break even. So break even, total revenue equals total cost. So S times Q equals fixed cost plus variable cost times Q. When we solve this, this has to come over. SQ minus variable cost times Q equals fixed cost. And so then we factor out the Q. So Q outside of S, take away variable cost equals fixed cost. So Q equals fixed cost divided by S minus VC. And our fixed cost was $6.95. Our selling price was 37 minus 9. Let's see what that gives us. 695. Oh, first 37 minus 9 is 28. So 695 divided by 28 is 24 or 24 units, 0.82. But we're going to have to round that up to 25. So did that make sense? I'm not quite sure where you got the 1,200. We could have done this a lot quicker. we could have just remembered that break-even quantity equals fixed cost divided by the contribution margin. And contribution margin is S minus VC equals 28. You want to look at question 3? Okay, I'll save this. So Tara makes and sells scarves for children and adults. She's able to sell the scarves for $15. So S equals 15. Materials cost 7. So variable cost equals 7. Fixed cost equals 247. And she estimates that she can sell 80. Q equals 80. Oh no, that's not, that's the capacity. So let's get rid of that. Capacity equals 80. And we've figured out that we need to do the contribution margin equals 15 minus 7 equals 8. Okay, you got it. I'll finish it anyway. So break even quantity equals fixed cost divided by contribution margin equals 247 over 8. And 247 divided by 8 equals 30.88. But we're going to round that up to 31. But you got that right, so that's good. You want to look at question 4 and 5. Okay, 4, you got part of it right. So we'll keep this answer because you got it. And we'll get rid of this one. So how many games do they need to sell to make at least 470 per month? So when we're doing break even, so for break even, we do total revenue equals total cost at break even. But if we're going to make a profit, we've got to go total revenue minus total cost equals profit. So this was at break even. So we've got to use this formula, and let's put the information we have in here. They can purchase these games for $17.73. So their variable cost equals $17.73. They can sell them for $31.99. And there looks like their only fixed cost is advertising. Fixed cost equals $613.18. So let's put those into this equation. Total revenue, S times Q minus fixed cost plus variable cost times Q equals profit. And we're being told they want to make a profit. Profit equals 470. So S, here we have $31.99. But we don't know the quantity. That's what we're looking for. Minus fixed costs of 613.18 plus variable costs of 17.73 times Q. And this equals 470. So the only unknown we have is the letter Q. So let's get rid of the brackets first. 3199 Q minus 613.18 minus 1773 Q equals 470. And now we can bring these two Q's together. Oh, sorry, not 460. 470. $470 plus 613.18. So now we have to do some math. 31.99 minus 17.73. So over here we get 14.26 Q. And over here, what do we have? 470 plus 613.18. I'm getting 786.18. So Q must equal 786.18 divided by 14.26. And I'm getting 54.75. 55. And that's not what Moodle wants. Moodle wants 76. So what did we do wrong here? 470 per month. Let's try the math over again. 31.99 minus 17.73. So the 1426 is good. Yeah, what did I do wrong there? 470 plus 613.18 is indeed 1083.18. I don't know what I did there. That's ridiculous. I must have plugged something wrong into my calculator. So 1083.18, 1083.18. So 1083.18 divided by 14.26 is 75.96, which will be 76, which is much better because that's the answer Moodle wants. Sorry about that. I don't know what happened. I blanked out somehow. So does that make sense? Okay, let's try question number 5. Okay. So Old Time Fashion specializes in hats modeled after fashions from the past. It purchases these hats for $12.28. So that's a variable cost. It can provide a custom service to print the new owner's name on the hat band. The printing machine costs $270 per month. So that's going to be a fixed cost. And if Old Time sells the hats at a price of $15.95, so selling price equals $15.95. How many hats need to be sold for a profit of $4.10 per month? So the same situation, we've got to do total revenue minus total cost equals profit, and total revenue is S times Q. This all has to be in a bracket. Fixed cost plus variable cost times Q equals profit. And what do we know? We know S is 15.95. but we don't know Q. That's what we're being asked. The fixed costs we know are 270. And the variable costs is 1228. And the profit turns out to be 270. So we're doing the same calculation. We got to get rid of the bracket. So 15.95 Q minus 270 minus 12.28 Q. Yeah. This isn't 270. They want to make a profit of 410. Yeah, thank you. 410. 410. So now we've got to bring our Q's together. 15.95 Q minus 12.28 Q equals 410 plus 270. So 15.95 plus 12.28. Oh no, minus, try that. 15.95 minus 12.28 is 3.67 Q equals 410 plus 270. I'm getting 680 here. So Q equals 680 over 3.67. So 680 divided by 3.67. 185.29, but that has to be rounded up to 186. Does that make sense? Why did we round it up? They want to make a profit of $410 a month, right? But if we round it down, they won't be making quite enough money. Let's see how that works. We know that their revenue, total revenue, equals S times Q. If we go down to 185 times, let's write this the other way, 15.95 times 185. Let's see what their revenues would be. 15.95 times 185. This would make their revenues 2950.75, and their cost would be 270 plus 12.28 times 185. So 185 times 12.28 plus 270. The cost would be 254.80. So revenue 2950.75 minus, oh, that didn't work, 2541. 2541.80. What is that equal to? 2950.75 minus 2541.80. And that would make 409.67. But they want to make 410. So rounding it down, they wouldn't quite make enough money. If they round it up, they'll make slightly more than 410, but they want to make at least 410. So Nikki, does that make sense? Why we have to round it up, even though the normal rules of rounding would cause us to round down. But whenever you're trying to make at least a certain amount of money, whatever this is, you're gonna have to round it up. Don't round it off to the closest. So you also wanted to look at question number 10. Let's take a look here. So let's take a look at part A here. Substop selling sandwiches is located on a busy corner near many other businesses. The shop's busiest time is during the midday period. Rent for the location is $840, so we know that's going to be a fixed cost. And wages amount to $2,498 per month. So those wages are going to be the same. So those are also a fixed cost. 2,498. Variable costs consists of supplies and sandwich ingredients. So variable costs equals 220. The subs are to be sold at a price of $5.69. So S equals 5.69. And how many to break even? So we know that break even equals fixed costs divided by the contribution margin. So first off, let's figure out what our fixed costs actually are. 2,498 plus 840. So 3,338. And let's figure out our contribution margin equals S minus VC. S is 5.69 minus 2.20. So 5.69 minus 2.2. $349. So we can figure out this down here. 3,338 divided by 3.49. So 3,338 divided by 3.49. And I'm getting 956.45. But again, we're going to round it up because they won't quite break even. It's okay for them to be doing slightly better, but they can't do slightly less. Round up to 6. Oh no. 957. And that's indeed what Moodle wants there. So that's part A. Let's copy all this and see if we can put it on the next page. Control. Okay, let's get rid of A. We don't need it anymore. Let's just look at part B now. If the shop increases variable cost by 20 cents per sandwich, so variable cost was $2.20, and they're going to go over to using real mayonnaise instead of Miracle Whip and add 20 cents. So I'm going to take a big chance and say this is now going to be $2.40 per sandwich. How many sandwiches must it sell to break even? So the only thing that's changed is the variable cost. So fixed cost still equals the 840 plus 2,498, which was 3,338. And they're still selling them at 569. S equals 5.69. So we have to calculate the contribution margin again. 5.69 minus 240. This has come down to 329. And so break even equals fixed costs of 3,338 over 329. Let's see what that works out to be. try that again. 3338 divided by 3.29. I'm getting 1014.59, but we've got to round that up to 1015. And Moodle would have liked that. So let's try the next one. So now we can get rid of A and B. And we're only worried about part C here. If the rent increases by 10%, so let's calculate fixed costs again. Equals 840 plus 10% times 840. Find out what that is. It's $84 plus 840. So now the rent is $924. So we should put a different label on that. That's the rent. $924 plus the 2498. See what that equals. $3,422. And they're asking us about profit because they tell us they're selling 1,600 sandwiches. And so S is still 5.69. And quantity, or no, variable cost is back to 220 because these are all independent questions. So as we're looking for profit, we've got to go total revenue minus total cost equals profit. Total revenue is S times Q. So what do we know here? We know S is 5.69. And we know they're going to sell 1,600 sandwiches. We know the fixed costs are 3,422 plus the variable cost of 220, but times 1,600 sandwiches. So we can do a whole bunch of math here. 5.69 times 1600. I'm getting 9104. $3,422 there. So 2.2 times 1600 is 3520. So 9104. So 3520 plus 3422. This comes to 6942. And I'm getting 2162. So, does that make any sense? And that's exactly what you got. And that's the answer Moodle wants. So, we're good with that. Let's try the next one. So now we don't have to worry about A, B, or C. Just D here. So if the sandwich price was reduced by 20 cents, so price S equals 5.69 minus 0.20, 5.49. So they're now selling them for $5.49. Their variable cost is still $2.20, and their fixed costs are still $8.40. Plus the 2,498, which was 3,338. Make 100% sure of that. 840 plus 2,498, 3,338. And they're making a profit, so we're still doing total revenue minus total cost equals profit. And total revenue is S times Q minus bracket fixed cost plus variable cost times Q equals profit. So we can plug in everything we know here. Our S is now 549. We don't know Q in this case. Fixed costs are the 3,338. Variable cost we know, 220. We don't know the quantity, but we know they're trying to make $1,000. So we have to sort all this nonsense out, get rid of the bracket. 5.49Q minus 2.20 Q equals 1,000 plus 3,338. So 5.49 minus 2.2 gives us 3.29 Q. And over here, what do we get? Looks like 4,338. Four, 338. Let's see what that equals. 4,338 divided by 3.29. I'm getting a quantity of 1318.54. But again, we're going to have to round it up. 1319. And that's the answer Moodle was looking for. So let's get rid of part D here. Don't think I can. That worked. This is part B. So let's get rid of C and D here. This is A. So we'll get rid of everything we don't need there. So did that make sense with those questions? I'll save those. I'll send you these snapshots. So Nikki, did you have any other questions you want to look at today? Okay. I'll wait till that downloads, and I'll send you the link for the YouTube. Okay. Have a good day. We'll see you tomorrow.